Let's dive into the world of the JavaScript Document Object Model, or DOM. This is a fundamental concept in web development. We will explore its structure, how to navigate through it, and how to manipulate it with JavaScript. Understanding the DOM is crucial for building interactive web pages. The Document Object Model, or DOM, represents an HTML document as a tree-like structure. Each HTML element in the document becomes a node in this tree. Elements can contain other elements forming parent-child relationships. These elements are related as parents, children, and siblings. The document itself is the root node of this tree. This structure allows JavaScript to access and manipulate the elements, content, and attributes of an HTML document dynamically. Here's how a simple HTML structure is represented in the DOM. The HTML code shown consists of a div with the class container, which contains a heading 1 element with the ID title, and a paragraph element with the class content. In the DOM tree visualization, the div with class container is the parent node. The heading 1 with the ID title and the paragraph with the class content are its children. Each element further contains text nodes that represent the actual text content. This illustration shows how the HTML source code is structured as a hierarchical tree of nodes in the DOM. In the DOM, different kinds of nodes exist. The most common ones are element nodes, text nodes, comment nodes, and document nodes. Element nodes represent HTML elements like div, paragraph, or span. They have a node type of 1. Text nodes represent the actual text content inside elements, with a node type of 3. Comment nodes represent HTML comments in the document. They have a node type of 8. Document node is the root of the entire tree with node type 9. Understanding these node types is important for working with DOM effectively. DOM nodes have several properties that allow us to access and modify their characteristics. The node name property returns the name of the node, which is the tag name for element nodes. The node value gets or sets the value of the node, which is often text content for text nodes. The node type returns a number indicating the type of the node. The text content property allows you to get or set the text content of a node and its descendants. Lastly, the inner HTML property allows you to get or set the HTML content inside an element. These properties are crucial for retrieving and changing various aspects of the DOM. DOM elements have relationships with each other. The parent node refers to the immediate parent node of an element. The child nodes returns a list of all child nodes, including text and comment nodes. First child and last child represent the first and last child nodes respectively. Previous sibling and next sibling allow you to access nodes at the same level. Additionally, there are element-specific relationships like parent element, children, first element child, last element child, previous element sibling, and next element sibling, which only consider element nodes and not other types of nodes like text or comments. These properties are crucial for navigating the DOM tree structure. To navigate through the DOM effectively, various traversal methods are available. getElementById gets an element by its ID. Query selectors like querySelector, which returns the first element matching the provided CSS selector, and querySelectorAll, which returns a list of all elements matching the selector, are also very useful. There are methods to get elements by class name, get elements by class name, and by tag name, get elements by tag name. These methods help in locating and accessing specific elements or collections of elements within the DOM tree. querySelectorAll returns a static node list, and getElementsBy methods return a live node list. More advanced techniques exist for traversing the DOM. Complex CSS selectors with querySelectorAll allows you to select specific elements based on their hierarchical structure and other CSS rules. You can also filter elements by condition using JavaScript array methods like filter. For finding the closest ancestor based on a selector, the closest method is useful. TreeWalker is an advanced way to traverse DOM tree that gives a customized filter. The contains method lets you know if a particular node is the descendant of another node, and the hasChildNodes method checks whether a node has children or not. The DOM is not just about reading data, it also provides manipulation methods. New elements can be created using createElement, and can be added to the DOM using appendChild, insertBefore, or insertAdjacentElement. Similarly, elements can be removed using remove and removeChild, and they can be replaced using replaceChild or replaceWith. The classes of an element can be modified using the classlist property with methods like add, remove, and toggle. Attributes can be set or removed using setAttribute and removeAttribute. The inline styles can be accessed and modified using style property. These methods are essential for creating dynamic user interfaces. When manipulating the DOM, certain best practices should be followed for optimization. For instance, instead of multiple individual updates, try to batch DOM changes. Use a document fragment to make changes to the elements while they're detached from the DOM, then add them back. Avoid direct updates to the DOM whenever possible. Always cache the DOM queries, especially the ones that are accessed frequently. Use event delegation for dynamic elements and always minimize reflows and repaints. Modern frameworks implement the concept of virtual DOM to optimize the changes in DOM. Remove event listeners and clean up references when removing elements to prevent memory leaks. Use request animation frame for smooth visual updates. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.